Hello, welcome to L to R Math Tutoring. And today we'll be going through some different drug calculations. So the first one is on the screen. The best thing with the drug calculations is to look at what the question is asking you, and then always look at your answer. How's your answer end up? So for this one, the question is asking how many mLs will you need to administer? And it wants us to write the numerical value in mLs only. So the doctor's order is your patient is to receive 5 milligrams of ondansetron IV. And what you have on hand is 4 milligrams per 2 ml. So how many mLs will you need to administer? So for this problem, we're going to go to the whiteboard. So you're going to need to know your doctor's order, which is 5 milligrams, okay, and what you have on hand, which is 4 milligrams per 2 ml. So here we are at the whiteboard. So our doctor's order goes on top, and that is 5 milligrams, okay? What we have on hand goes on the bottom, which is 4 milligrams. Milligrams crosses itself out, and we have 5 divided by 4 times 2 mLs. And for this answer, you should have gotten 2.5, and that's your answer, 2.5 mLs. Okay, I like to do that, keep it simple, stupid kind of math. So I just break it down real easy, and hopefully you can do it in a few minutes if you know the formula and you know what the question is actually asking you. Okay, all right, let's go to the next one. All right, the next one states, what is the flow rate in drops per minute? Okay, so that drops per minute tells us how to set up the problem. So anytime you have a drops per minute problem, you need three things, I'm sorry. You need the volume, okay, which is usually always going to be in mLs, okay? You need your time in minutes, okay? So here our time is 5 hours, and you need your drip factor, which is 12 GTT. Now, sometimes what you'll see is they'll put PD drop or micro drop. Okay, if they put that on there, then your drip factor is automatically 60. In that case, they might not give you the drip factor. Okay, so here's our question. The physician orders 500 mLs of normal saline to infuse over 5 hours. The IV drip factor is 12 drops per ml. What is the flow rate in drops per minute? Okay, so now let's go to the whiteboard. And here we're going to write our problem. So we have 500 mLs of normal saline. That's our total volume. Again, your total volume is going to be in mLs. On the time that it's going over, so it's total volume over total time in minutes. Okay, so right now our time is 5 hours. Okay, and then it's times our drop factor, which is 12. Okay, and that's 12 drops per minute, per ml. Sorry. Okay, so now what you're going to do is you're going to convert your 5 hours into minutes. Okay, since there's 60 minutes in an hour, it's going to be 5 times 60. That should give us 300 minutes. Okay, now we're going to take our total volume, which is 500. And we're going to divide that by our minutes, which is 300. And we're going to multiply the whole thing times 12. And that gives us a nice equal 20 drops per minute. Okay. And we are always going to round these to a whole number. So if it was 20.4 or less, it would go to 20. It was 20.5 and higher, it would go to 21 drops. We will erase this and go back to our problems. Okay, so again, look at what your question is asking you. All right, our question is asking us for the flow rate in drops per minute. For flow rate in drops per minute, you need three things. You need your total volume in mLs. You need your minutes or your time in minutes, your total time in minutes, and you need your drip factor. Okay, so our total volume here is 500 mLs. It's going to infuse over 50 minutes. So in this case, our time is already in minutes. We don't have to convert. And then we're going to multiply that times our drip factor. Okay, so now when we go to the whiteboard, your problem should be set up like this. Our total volume is 500 mLs. Our time is 50 minutes. And our drop factor is 10. Okay, so we have 500 divided by 50 times 10. And you should have gotten a drop factor of 100 drops per minute. Okay, so here we have calculate the flow rate. Okay, now it didn't tell us how they want it, but if you look at your answer there, it says drips per minute. You have a volume here, okay, and you have a time here, and you have a drip rate. It's a micro drip, which I just said was what? 60 drops per minute, right? So let's just calculate what we have here. So we have 1 liter of normal saline, which is equal to 1,000 mLs. We have 10 hours. That's our time, right? We can convert that into minutes once we get to the whiteboard. And then we have our micro drip, which is 60 drops per minute. Okay, so let's go to the whiteboard. Okay, so our total volume is 1,000 mLs. It's going to go over 10 hours. So we're going to multiply that times 60 to get our time in minutes. And that is going to be times our drip factor, which is going to be 60. Okay. So now we have 10 hours times 60. which is 600 minutes. We're going to take our 1,000. Divide that by the 600. And multiply that times 60. And you should have gotten 100. I always like to do my math twice, just to make sure I didn't make a mistake. Okay, so 1,000 divided by 600 times 60. Okay, our next question asks us to draw up 18 units from a vial labeled 30 units in 5 mLs. Write the numerical value only in mLs and round it to the nearest 10th. Okay, so draw up means that's our order. Okay, so we have 18 units ordered. And what we have on hand is 30 units in 5 mLs. And we're rounding to the nearest 10th. Okay, so we're going to take our order that goes on top. $18 units. What we have on hand is 30 units per 5 mL. So now you just have to do the math. $18 divided by 30 times 5. And you should have gotten 3 mLs. I'm sorry, 3 units. Oh, 3 mLs. I said it right the first time. Don't confuse your own self, teacher. All right. The order is written for an addition of 80 MEQs to an IV solution. The available vial is labeled 20 MEQs in 10 mLs. So we have 80 MEQs ordered. On hand, we have 20 MEQs per 10 mL. So let's set the problem up. $80 is ordered. We have 20 per 10 mL. So 80 divided by 20. times 10, and you should have gotten 40. Okay, this one here, we have a patient who has an annual physical and they weigh 220 pounds and they want us to convert it to kilograms. So a good way to remember this is that ladies always like to be weighed in kilograms, not pounds. So when we're going from pounds to kilograms, okay, pounds to kilograms, it's 220 pounds divided by 2.2. Kilograms should always be about half what your pounds are. So we get 100 pounds. Okay, and when you're going the other way, okay, from kilograms to pounds, pounds is going to be more. So if I weigh 50 kilograms, to multiply that times 2.2, right? And what'd you get? You'd have got 110 pounds. Okay. 110 pounds. All right, now, other conversions, okay? Centimeters to inches, okay? If I have 84 centimeters, how many inches do I have? Okay, so think about a centimeter like being a worm. It's long. Okay, so in that case, I'm gonna divide by 2.54 to get my inches. Okay. The inch is shorter than the centimeter, so 84 divided by 2.54 equals 33.07, blah, blah, blah. Okay. In inches. Okay. And if I'm going the other way, my worm in centimeters, okay, remember, is longer than my inch. So if I have 5 inches, I'm going to multiply it times 2.54. And that gives me 12.7 centimeters. Okay. All right. Now, when you think about other conversions that you might see, okay, you might see grams to milligrams to micrograms. Okay, So when you're going from grams towards micrograms and milligrams, okay, grams to milligrams, milligrams to microgram, you're going to multiply times 1,000. Okay, and when you're going the other way, from micrograms towards grams, micrograms to milligrams, okay, you're going to divide by 1,000. All right, the other option is if you're going to the left from micrograms to grams, okay, you have 500 micrograms, and you're going to milligrams, you're going to move the decimal 3 places, 1, 2, 3. So now you would have 0.5 milligrams if you had 500 micrograms. Now, if you take 500 and divide it by 1,000, that's what you should get. Okay, and it's the same thing if you're doing it the other way, going from grams to milligrams to micrograms. You can also move the decimal. So if you had 1,000 milligrams and you want to go to micrograms, you can move it. Okay, 3 spots to the right. 1, 2, 3. So your decimal. Sorry, I moved the decimal from the wrong space. Let me go back there. Your decimal would be here. You would move it 3 more spaces if you had 1,000 milligrams. All right, 1, 2, 3. So you would add 3 zeros, 2, 3. Okay. Or 1,000 times 1,000. Which is sometimes easier. Okay. So if we counted the zeros there, 1, 2, then you would have 1,000,000. Okay. All right. So that's the most of the conversions that you see. That there are a couple of more. Okay. You want to know that 1 teaspoon equals 5 mLs. Okay. 1 tablespoon equals 15 mLs. Okay. So if you had 1,000 mLs and you wanted to know how many teaspoons were in it, you would divide it by 5. So there would be 200 teaspoons in 1,000 mLs. Okay. All right, let's try some other problems. Okay, so here we have a problem. The prescription reads to administer an IV dose of 400,000 units of penicillin The label on the 10 ml ampule sent from the pharmacy reads penicillin, 300,000 units per ml. The nurse prepares how much medication to administer the correct dose. Record your answer using 1 decimal. Okay, so here we have a simple question. Okay, it looks like a lot, but it's really not. All right. First of all, whenever you see a 10 ml ampoule, okay, that just means that you may have enough in there for multiple doses because the pharmacy doesn't want to walk up and down the steps 1,000 times to bring you the medication. Okay, but just go back to that simple rule of thumb. Okay, what is the order? So the prescription reads 400,000 units. Doesn't really matter what it is. It's 400,000 units. Okay. So let's put our 400,000 down because that's our doctor's order that is going to go on the top. And then on hand, we have what the pharmacy sent, which is 300,000 units, okay, per ml. So let's go to our whiteboard, okay, and we're going to write it. So we have 400,000 ordered, that goes on top. On hand, we have 300,000 per ml. Okay. Now, for me, I don't like to do all those zeros on the calculator. So as long as you have an even number of zeros, or as long as you cross off an even number of zeros, we can take some of these away and do a little bit simpler math. So cross out an even number, 1 at the bottom, 1 at the top, 1 at the bottom, 1 at the top. Okay. We have an even number here. We can cross them all out. Okay, and that leaves us with 4 divided by 3, which is going to give us the same answer as if we used all those zeros. So 4 divided by 3 equals 1.33 and so on. Okay, our answer wants us to do it with 1 decimal. Okay, so for 1 decimal, that would be 1.3 mLs. Again, we have 1.33. So if we were rounding to the nearest tenth, we're going to use that 100th place, which is that second 3, and that's going to determine whether we go 1.3 or 1.4. So again, if that second number is 4 or less, then it goes to, it stays at 1.3. If that number is 5 or higher, then this would be 1.4 mLs. Okay, let's check our answer. 1.3 mLs, and there is your formula again. Okay. Okay, so this order says the nurse prepares how many mLs of potassium chloride to administer the correct dose. Remember, I said read the question first. So it's looking for an answer in mLs. Okay, now we'll read the whole thing. The prescription reads potassium chloride, that 30 MEQs to be added to a 1,000 ml normal saline and be administered over a 10-hour period. The label on the medication bottle reads 40 MEQ per 20 ml. Now with this, we're adding the potassium chloride to the bottle. So our order here is 30 MEQs of potassium chloride. Okay. What we have on hand is 40 MEQs per 20 ml. Okay. So we're going to the whiteboard. Let me just go back. Okay, so the order is 30 MEQs, and what we have on hand is 40 MEQs per 20 ml. So we have 30 MEQs ordered. 40 MEQs times 20 on hand. Okay, so we have 30 divided by 40. Times 20. And that should have gave you 15 mLs. Okay, let's see if that's correct. And it is. Okay, and there's your problem. Let me just make sure this is still sharing the screen I want to share, and it should be. Okay. All right, let's go to the next one. Okay, so here it says the nurse prepares how many mLs of medication to administer the correct dose. So again, we have to know what the doctor ordered versus what we have on hand. Okay, so we have a prescription which reads clindamycin phosphate 0.3 grams in 50 mLs of normal saline to be administered over 30 minutes. All right, the label reads 600 milligrams in 6 mLs. Okay, so our order is 0.3 grams. Okay, and what we have on hand is 900 milligrams per 6 mLs. Okay, so first thing we got to do is either convert the 0.3 grams or we got to convert the 900 milligrams. Okay, usually you have to convert your doctor's order because you can't convert what's on hand. But since we're doing math, if it's easier for you to convert it one way or the other, then there's no really right or wrong way as long as you get the answer right. Okay, so if we look at the top, we can convert that grams to milligrams. Remember for this one, our order is 0.3 grams, and what we have on hand is the 900 milligrams per 6 ml. Okay, so you're going to take this 0.3 and we can multiply that times 1,000. All right, to take that grams to milligrams. All right, so do that math there. 0.3 times 1,000, and you should have gotten 300 milligrams. Okay. So now we'll cross this out and we'll put our 300 milligrams. Okay, so now we have 300 divided by 900 times 6. And what you should have ended up with is 2 mLs. Okay. And if that's what you got, you were correct. Okay, and here's your rationale. Okay, here we go. Let's do another conversion just so you get used to it. So the prescription reads phenytoin 0.2 grams orally daily, and the medication label states that each capsule is 100 milligrams. So our question is asking us, the nurse prepares how many capsules to administer one dose. All right, so for this calculation, our answer is going to end up in capsules. Okay, the doctor ordered 0.2 grams. And what we have on hand is 100 milligrams times one capsule. Okay, so we go to our board. Our order is 0.2 grams. What we have on hand is milligrams. And that's times one cap. Okay, so again, it's easier to convert our doctor's order. In this case, it's 0.2 grams. So we can convert that to milligrams by taking 0.2 and multiplying times 1,000. And that should have gave you 200 milligrams. Okay, then 200 divided by 100. Times 1. And that should have gave you 2 capsules. Okay, there's your rationale. There's a little typo there. You're converting the 0.2 grams. There was a little typo in that rationale, but 0.2 grams you're converting to milligrams. Okay. Back to our problems. Okay, now let's try another drip factor. Okay, so the question states the nurse sets the flow rate at how many drops per minute. Okay, prescription reads 1,000 mLs. That's your total volume, right? You need 3 things here: total volume, total time in minutes, and the drop factor. So the 1,000 mLs represents your total volume. Okay, it's going over 8 hours. That's your total time. And the drop factor is 15. Okay, so we have 1,000 mLs. Our time is 8 hours. We just need to convert that into minutes. So 8 times 60 is 480. And then we're multiplying that times our drop factor. So we have 1,000 divided by 480 times 15. And you should have got 31 drops. actually you would get 31.25, but because it's a drop, we give it in whole numbers. 31.2 is what we go by. Since the 2 is less than 5, it goes to 31 drops per minute when we're rounding to the nearest 10. So we will type in 31 here. Okay, and that's your answer, 31 drops per minute. Now, Saunders does it a little bit different than me, but I do it, keep a simple, stupid math. So that's the way I like to do it. I like to keep it flowing nice and easy. Okay, here we go. Prescription reads 3,000 mLs of D5W to be administered over a 24-hour period. The nurse determines how many mLs per hour would be administered to the client. So what is our question asking us? The nurse determines that how many mLs per hour will be administered to the client. So you over there on the side see that this formula is going to end up mLs per hour. So for mLs per hour, you need your total volume in mLs, which in this case is going to be 3,000. Okay, and your total time in hours. And in this case, it's going to be a 24-hour period. Okay, so all you have to do is take your 3,000, which is your total volume, divide it by the 24. You do it on the whiteboard, just in case someone doesn't understand. Okay, so we have a total volume of 3,000. And it's going over a 24-hour period. So for mLs per hour, would be 125. And there is your rationale. Okay, prescription reads levothyroxine, 150 micrograms orally daily. The label reads levothyroxine, 0.1 milligrams. The nurse administers how many tablets? Okay, so the order is 150 micrograms daily. And what we have on hand is 0.1 milligram per tablet. Okay. Okay, so here we go. We have 150 micrograms ordered. That goes on top. That's the doctor's order. 0.1 milligram is what we have on hand. And that's per tab. Okay, so again, if you're going from micrograms to milligrams, you're going to go to the left. So we're going to divide by 1,000. Okay, and again, we want to convert the doctor's order because it's easier to convert that than what you have on hand. So we have 150 micrograms. We're going to divide that by 1,000. And you should have gotten 0.15 milligrams. Okay. Take that 0.15 0.15 milligrams and divide it by 0.1. And you should get 1.5 caps. Okay, and there is your rationale. I'm just going to pause for a minute and find some other questions for us to do here. Okay, here we have a question on reconstitution. Okay, so for this one, the physician ordered kanamycin 200 milligrams IN. Okay. The dose available and reconstitution directions say add 2.3 mLs of sterile water to make kanamycin 1 gram per 3 mLs. So really what you need from this is your doctor's order, which is the 200 milligrams, okay, and what you have on hand. So your final concentration or what you have at the end, that's what you have on hand. So what we have on hand here is 1 gram per 3 mLs. Okay, so let's go to our whiteboard. Okay, our order is 200 milligrams. What we have on hand is 1 gram per 3 mLs. And now we're just going to convert, okay? You can either convert the milligrams to grams, okay, or the gram to milligrams. So I'm going to do the gram to milligrams just because it's a little easier conversion. All right, so we multiply that times 1,000. And then we're going to take 200 divided by 1,000. And then we're going to multiply that times 3. And you should have gotten 0.6 mLs. And let's see if we have an answer choice that says 0.6 mLs. Ah, look at that, number C. Okay, awesome. Okay, here we have heparin. Okay, so we have 800 units ordered. And on hand, we have 5,000 units per ml. Okay, so you're just going to take your doctor's order, which goes on top. And I always remember that the doctor makes the most money, put the doctor on top. Okay. So what we have is 800 units ordered. On hand, we have 5,000 units. And it's per 1 ml. So if it just says ml, it's assumed that it's 1, okay? Again, if you wanted to cross the some of the zeros off, you could. As long as you do the same amount on the top as the bottom. So we have 1, 1, 2, 2. and then it would be 8 divided by 50, okay? Or you can do 800 divided by 5,000. Should get the same answer either way. And then you're multiplying it times 1. Okay, let's go back to our. Oh, and look at that, D, 0.16, okay? Again, always do your math twice. Okay. All right. That's going to conclude this session for today. And I'm going to try to tape another session tomorrow to show you some additional doses. Have a good night.